Hello, algebra students. Today we're looking at section 6.6, Rationalized Denominators. In this section, you will never leave a radical in your denominator. So you can follow a process to write the radical expression in a form that does not have a radical in the denominator. It's important to realize you're not changing the value of the expression at all. You want the expression to be the same, but just in a different form. And this has been considered important, in some sense better to write these radical expressions without radicals in the denominator. And so we want to learn how to do that. So we have example 1, and we have the radical expression here, the square root of 3 divided by the square root of 2. It does have a radical in the denominator, right? The square root of 2 is in the denominator. So we want to see, how do we rewrite it in a way that does not have that radical in the denominator? And the trick is to simply multiply the numerator and the denominator by the square root of 2. So that same square root that is in our denominator, we multiply the numerator and the denominator by that. Now, that doesn't change the value of the fraction that we have, right? Because if you multiply the numerator and the denominator by the same thing, it won't change. It won't change the fraction itself. It's just going to be in a different form. For example, if you have 1/2 fraction, you multiply the numerator and the denominator. Let's see, I'll do it like this. By 6. Just going to multiply the numerator by 6, multiply the denominator by 6. Now we get 6 over 12. Well, that still equals 1/2, right? You have not changed it. You can always multiply the numerator and the denominator by the same number, and you're not changing it. But it has to be the same number. Okay, you can't just multiply the denominator by what you want to multiply it by and ignore the numerator. You have to multiply the numerator by that number as well. So we won't change the fraction when we do this, and we choose to use that square root of 2 because as we have down here, when you multiply a single term in a square root radical by exactly that same term in a square root radical, the radical sign cancels out. So we have 2 in the radical, and we just multiply that by another radical that also has 2. It cancels out, and it gives us 2. Not the square root of 2 anymore, just 2. And we say it canceled out, and we can see that here. We see what happens when we take the square root of 2 times the square root of 2. Well, that gives you the square root of 4, right? You multiply the 2 times the 2 inside the radical, as we learned the other day, gives you the square root of 4, which is 2. And of course, another way to think of it is the square root of 2 by definition is just the thing that when you multiply it by itself, you get 2. And so we multiply by itself, we should get 2, and we do. So this will get rid of the radical in the denominator every time. We now have a denominator that does not have a radical. The numerator still does, but that's okay. The goal is to get the radical out of the denominator. Okay, so let's look at some examples. Now, we can do this after we fully simplify the expression. So we might go ahead and simplify this. We have a quotient of two radicals, so we can take the radical of the quotient. And this time I'm going to go ahead and write them inside a radical like this. I think that's helpful sometimes. Okay. And our new radical will have that number 2/3, and it will have x. We subtract exponents, we have x to the second power, right? And actually, I'm just going to rewrite that like this. Okay, and that's all under that radical. So now we've simplified it. We've subtracted exponents, right, of the variable to get that simplified as much as we can. Now we split this up to simplify it further, and we have on the numerator is that, and the denominator is the square root of 3. So this is the way you deal with this when you have a denominator inside the radical. Go ahead and split it into the 2. But, of course, now we have the denominator of our fraction has this radical in it. And we actually haven't quite finished. I have to go ahead and simplify that numerator, right? It's because there's an x in there. X squared, that is. So that's a group of 2 x's. So we bring out an x, and that leaves 2 and the square root of 3. And we want to get rid of that square root of 3 in the denominator, so we multiply the top and the bottom by the square root of 3. Actually, I'm not going to put the dot there because we have parentheses to sort of separate them and make it clear. We don't need to write the dot for times. Okay, so the numerator, we just combine. We have the x still there on the outside, and we have 2 times 3 on the inside. Okay, and then the denominator, we have square root of 3 times the square root of 3. That's 3. We've done what we needed to do. Just go ahead and simplify by combining that 2 times 3 inside the radical as 6. And that's it. Okay, so we had it right here as simple as it can get, really, but the denominator's not rationalized. So if we're following the convention of rationalizing the denominator, we can't leave it like that. Okay, so go ahead and finish it and get it to a point like this, where you've caked everything. We took the x out like we needed to because we had x squared inside. Once you've done all that, then you look at rationalizing the denominator. Okay. Okay, so let's look at the next one. So we will go ahead and do our division just like we did on the first one. This time it's a little easier in a way because we don't have that fraction We had the 2/3 to deal with in the one above. This time we just divide the 16 by the 8. We get 2. For the x, we get a negative exponent, x to the -3. And the y just cancels, right? Y squared over y squared is cancels out. Okay, so we still have to write this as a fraction, though, of course, because of this negative exponent. So we'll go ahead. I'll write this step where we have that. Okay, the exponent is negative, so we move the base and the exponent to the denominator and make the exponent positive. And then we'll split those into the 2 radicals. And now we simplify. We can simplify that denominator because you have x cubed. So there's a group of 2 x's. Our index is 2. We need groups of 2. And we have that. We have one group of 2 in x to the 3rd power. So we bring out an x, and there's still an x inside left over, right? And on the top, you have the square root of 2. Now, there's nothing left to cake here. There's no more variables to pull out of the radical. It's done, except we've decided we're following the convention. We're not going to leave a radical in the denominator. So we need to get rid of that square root of x. So we just multiply by square root of x over, we don't have to write it that way, though. Multiply the top numerator by the square root of x and the denominator. So in the numerator, it all goes under the radical. We can combine them inside one radical, right? We're multiplying a radical expression, so multiply the radicands together, and that's 2, and x goes inside the radical. The radicands multiplied. And in the denominator, we have this x here, and then, of course, we multiply square root of x times the square root of x. That gives us another x. Okay, and so that's just x to the 2nd power. So let's write it like that. And that's it. There is a radical in the numerator. There's not a radical in the denominator. And so that was our goal. It's also simplified all the way. Okay. So that's all the examples we're going to look at that type of problem. We are going to learn another technique, though. Let's have to save this so that I can bring in the 2nd page. Page 2. Okay. So we're going to look at binomial denominators. When we have a binomial, it's a little more complicated. Binomial meaning 2 terms. And so here's how we do it. To rationalize, multiply by the conjugate. And so you may say, well, what's the conjugate? Well, here is what the conjugate is. A plus square root of b and a minus the square root of b are conjugates. Okay, that's what conjugate means. So look at this first one. We have this 5 minus the square root of 3 in the denominator. So in this kind of situation, it will not help to multiply the top and the bottom by the square root of 3. I'm writing this down, but it won't help. Because we would distribute that, right? And we would take, in the denominator, we would take the square root of 3 times the square root of 3. That would work. That would look good. That would just be 3. But we would also take it times the 5, and that would be 5 times the square root of 3. It still has a radical. Okay, so that won't work. The conjugate, though, will work. And let's just see how that plays out. So why don't we just do this over to the side, multiply out that conjugate or that denominator just so you see what happens. So we have 5 minus the square root of 3, and we're going to multiply that by the conjugate, which is 5 plus the square root of 3. So we distribute twice. We take 5 times 5. Okay, that's 25. We take the 5 times the square root of 3. That's positive 5 times the square root of 3. Then we take this one, negative square root of 3 times 5. Okay, that's negative 5 times the square root of 3. And then we take negative the square root of 3 times positive the square root of 3. Okay, that's negative, because it's a negative times a positive, but it's just negative 3, right? So that, with that multiplication, gets rid of the radical in that product. Square root of 3 times square root of 3 is just 3. It's negative because we had the negative sign. So now there's no radical in that term. There are radicals here, but look, they cancel out because one of them is plus 5 times the square root of 3. The other one is minus 5 times the square root of 3. So you just have 25 minus 3, which is 22, and no radical. And that will always work if you multiply by the conjugate. Okay? So when you do these, you don't really have to do this distributing. If you know the middle term's going to go away, okay, you can just look at this and say, okay, we're going to do it to this problem. We're going to multiply the top times 5 plus the square root of 3, because that's the conjugate of the denominator. And we also multiply the bottom by the same thing. And that denominator, we don't even have to write all this out once we know what happens, because we know the middle term goes away. So we just have to look at 5 times 5 is 25. And the negative square root of 3 times positive square root of 3 is negative 3. And that's it. And it's going to be 22. And the next step, we'll write down 22 in the denominator. And, you know, you can only do that and ignore the middle term. You ignore this times this, and you ignore this times this, because you know they cancel out, because you're using the conjugate, and it's always going to be a positive and a negative. It's going to work out and cancel those out. That's why you can just ignore those products of those two multiplications where I have the arrows. You know they'll cancel out. So the numerator, we just distribute that like normal. 5 times 5 is 25. 5 times the square root of 3 is just 5 times the square root of 3. Okay, and so that numerator cannot be simplified any further. That's it. Just rewrite it because the denominator is 25 minus 3, which is 22. And that's it. Okay? Let's look at, see how many more are we going to look at. Maybe just one more. No, we've got a couple of them. Okay. So same thing. This next one has both numbers in that binomial are radicals in this next one, right? But we still do it the same way. So we multiply that numerator by this conjugate, which is square root of 5 plus the square root of 2. Okay, since the one we have in our denominator has the minus, we just change that to plus, and that's the conjugate. Make sure it's always multiplied numerator and denominator by that conjugate. Okay, so do the denominator first. It doesn't really matter. We've got to do them both. The square root of 5 times the square root of 5 is 5. Negative square root of 2 times the square root of 2 is negative 2. We ignore the middle term. Isn't that fun to just ignore it? Because you know you usually cannot do that. Anytime you have any binomial, for example, this times another binomial, you have to multiply, you have to distribute twice, and you have to figure out what that middle term is, combine like terms and all that. So that is normal. Don't forget. The only reason we don't have to do that is because we know it will cancel out. So numerator, well, we just distribute here. So we have 3 times 3 times the square root of 2 times the square root of 5. And I'll write that off to the side so it doesn't make our calculation look real messy. You can do it in your head, but I'm going to go ahead and write it over here to make sure we all follow what's going on. I took the 3 times the square root of 5 times square root of 5. And one way to show this, we'll put them both in parentheses. What does that give us? Well, the 3 out front has nothing to multiply by it, right? It's the only number outside, so it just stays there. Inside, you just take the 2 times the 5 and get 10. Okay, so that's all there is to that. So that goes here. 3 times the square root of 10. That's that from that first distributing, that times that, right? So now we have to take that times this, and let's do that over to the side as well. 3 times the square root of 2 times this time the square root of 2. Okay, we have the number out front 3. It's just write it down. Square root of 2 times the square root of 2. That's 2, right? We could combine them inside the radical, have the square root of 4, which is 2. Okay, so we have 3 times 2, which equals 6. Okay. So we have, that's what goes right here. So the denominator, of course, simplifies to 3. The numerator is 3 times the square root of 10 plus 6. Now, we can simplify this because we can reduce this fraction. Okay, and that's because the same number divides into all 3 of these numbers. Okay, 3 goes into all of those. Okay, and because of that, we can divide each of those by 3. And so in the numerator, we just have square root of 10. Because we divide 3 times the square root of 10 by 3. 3's cancel, just the square root of 10. Divide 6 by 3, and that gives us 2. And divide 3 by 3 in the denominator, that gives us just 1. So we can write it without that, and that gives us square root of 10 plus 2. We're just writing it without the denominator because it's just 1 in the denominator, so we don't need to write it. And this is simplified answer. Okay, so one more. So we know the drill. Multiply numerator and denominator by that conjugate. So that conjugate is 3 minus the square root of 3. Okay, I like to do the denominators first because that's kind of our payoff. That's why we're doing this, to get rid of that rational, so get rid of the radical in the denominator. So again, ignore the middle term. 3 times 3 is 9, and the square root of 3 times negative square root of 3 is negative square root of negative 3. So the numerator now, this one's a little more work because we have to fully distribute this twice. You know, our numerator is just a more complicated numerator than we've had. The example above, the numerator was just a single term, 3 times the square root of 2. The one before that, the numerator of the original fraction was just 5. So they were simpler, but this time we have a difference of 2 radical expressions. We have the 5 times the square root of 3 minus the square root of 2. We have to multiply that out. So take 5 times the square root of 3 times 3. That gives us 15 times the square root of 3. Okay, take it times that. That gives us 5 times 3, right? And we could show that like this. Oh, wait a second, that's wrong. This is negative. Taking this times this again. I don't like leaving all those arrows, so I'll keep erasing them. But that's what we're multiplying. It's negative because we have a negative sign, and we could write it as 5 times the square root of 9 for now. We know that simplifies to 5 times 3, right? Whoops. 5 times the square root of 9. We'll simplify to 5 times 3. So now it's time to take this times that, and that's negative 3 times the square root of 2. And then we take this times this. Now that is, they're both negative, right? So negative times a negative is positive, and they're both radicals, so we have to multiply those radicands together. 2 times 3 is 6, and it's inside the radical because 2 and 3 are both inside. Okay, it's positive because we have negative times a negative, so that's a positive. Okay. So let me get rid of that arrow. Plus the square root of 6. Okay, so that numerator, we have to look for like terms. We have to make sure it's completely simplified. Well, we neglected to finish simplifying that second term, right? That's 5 times the square root of 9. We left it like that and said we'll fix it later. So square root of 9 is 3. 5 times 3 is 15. So that's just minus 15. And then we can't do anything with the next one. Negative 3 times the square root of 2. And then we have the square root of 6. And that's all over. The 9 minus 3 gave us 6. Okay. So we look at each of those terms and make sure they're simplified. First of all, they are. None of those radicals can be caked to get anything that's going to factor out and so on. There is one other thing we have to check for, though. Remember in this one above, we did have a common factor for all three of those numbers. So if there is something that we can factor out of all four of these plus the denominator, it has to come out of all 5 things. Okay, this, 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 and this. We have to be able to factor something out of all of those. And there is nothing. 3 goes into most of them, right? 3 goes into that. 3 goes into that. And that. And that. But 3 does not go into the square root of 6. Now there's a 3 inside the radical, but that doesn't help. We need something that divides evenly into the number that's outside the radical, okay, in order to reduce this. Okay, and there is not anything. So it's done. Okay, so the techniques for getting rid of the radical in the denominator, those are the 2 that we're going to use. And so that's all for now.